real valued function. When we say real valued function, what does it mean? Now, given that f is a function and there is a rule that guides the domain and the codomain of f. What is the domain of f? X. And what is the codomain of f? Y. Now, given a function f from x to y, meaning that x is a set that contains some numbers, and y is also a set that contains some numbers, but those numbers are generated by imputing x in that rule. What am I saying? X is a set that contains small letter x. So small letter x is representing every number in capital letter X. We call them inputs. Small letter y is an element in big Y. Big Y is representing a set, while small y is representing the numbers in that set. Now, this is how this function works. Every x that is substituted in f gives a result, and that result belongs to y. So x is the input and y is the output. X is always called the domain and y is called the codomain. Let me cite an example. If f of x is defined to be 3x plus 1, that is the rule that guides that function. Don't forget, f of x is also known as y. Now, if you look at the values of x, x contains numbers from 2 upward. That is our domain. Now, for every value of x that you impute in this formula, you will definitely get a value. And that value is referred to as an element in y. For example, when you input 2 into this formula, you get 7. 7 is a member of y, and 7 is an output. Now that you have the understanding of this, a real valued function is a function whose outputs are real numbers. It means that a real valued function is that function that whatever input you give it, it will always give you a real number as the output. That is, if f of x is always giving you real numbers, if the value of y is always a real number, then you can call that function a real valued function. The input could be integer. It is not focused on the input now. When you say real valued function, it is focused on what the output is. Note that if the inputs are real numbers, now we are trying to consider the input and output. If the inputs are real numbers and the output are real numbers, the name then extends to real valued function of real variable. Can you see the difference now? When you say real valued function, it is only the output when the output is real. When the input and output are not real, then you call it a real valued function of real variable. Now, there are other classification of functions. A single variable function. When do you say a function is single variable? A function that depends on one input to provide output, meaning that a function that has just one independent variable is the one that we refer to as a single valued function. An example is f of x equals x squared. When you look at this example, you see that it is not f of x and any other variable. It is f of x only. So it is a single variable function. There's the second classification is the multivariable function. Of course, since that one is single, then this one means that it depends on 2 or more inputs to produce its output. An example is f of x, y, 2 independent variable x and y. Can you see that? Now, what are the other classifications? Other classifications of functions. The first one is the algebraic function. When you say algebraic function, we have 2 kinds of functions under the algebraic function. The first one is the polynomial function. When we say polynomial function, it means every function that can be expressed or that the rule is defined in a polynomial form. Also, rational. Every function that can be expressed in form of a rational number can be referred to as algebraic function. An example is f of x equals x squared plus 2. Of course, x squared plus 2 is a polynomial. So that is why we can call this function an algebraic function. Another example is the f of x equals the square root of x plus 3. And of course, it is also an algebraic function. Another classification is the transcendental functions. The transcends there means that it is beyond algebra. It transcends algebra. That is where the name comes from. Transcendental functions. The first one under it is the exponential function. The next one is the logarithmic function. We have the trigonometric function, and we also have the inverse trigonometric functions. Of course, you can combine the trig and the inverse trig as trig. What are the examples under this? If you have a function that is defined as f of x equals e raised to power x, of course, that is an exponential function. Other two examples, when f of x is expressed to be in x, it means log x, the natural log of x, which is a logarithmic function. And when f of x is expressed as a trig, then you refer to it as a trig function. Now, what is a piecewise function? A piecewise function is that function that uses different rules or formula for different values of x. Take a look at this example. The example says that if x is less than 0, let your f of x be 2x. But if x is now 0 or greater than 0, let your f of x be x plus 3. What does that mean? It means that the function is in pieces. It is a function that uses different rules or formula for different values of x. This is the rule when the values of x are less than 0. And this is the other rule when the values of x are 0 upward. That is, it uses different rules on different parts of its domain.